Hello there. Pan and tilt are just fine when you work with fixtures and objects on fixed positions. When we add motion to one of these two, we need something else. Marker fixtures are virtual fixtures that allow you to move objects in your 3D stage environment. Think of them as reference points or guides that help other fixtures follow their movement. You can use marker fixtures to control fixtures, set pieces, or even stage props in a synchronized way. Markers can be used to move objects or as a target for them. For each object you want to move, you'll need a separate marker, and the same applies for each target. Let's get started by adding marker fixtures to your patch. First, head into the patch menu and select the Add Fixture option. Search for Marker in the Fixture library. For this tutorial, we'll choose a moving marker. The marker object is automatically recognized as a marker fixture type. You have the same options as with any other fixture, such as naming it, specifying quantity, and assigning an ID number. Markers need to be patched for them to display properly in the 3D window. Let's add two markers, one for moving objects and another as a target marker. Let's assign them a fixture ID starting in 2001 and create the markers in our patch. You could also recall the markers when programming using the keyword marker. Let's rename the first marker Hoist and the second one Actor. Now we need a truss to hang our fixtures on. This truss will move in sync with the marker, just like you would with intelligent hoists. Let's search the library for set, truss, and a 4-meter piece of truss. We only need one, so let's call it truss and assign fixture ID 3001. Once you've imported the truss, it's time to link it to your marker fixture. In the patch menu, select the truss and assign it as a child of the marker hoist fixture using the cut and paste method. This means the truss will now follow the marker's movement, staying aligned with its position in the 3D space. Any changes you make to the marker's position will automatically be applied to the truss. The same parent-child structure applies to the fixtures you want to hang on the truss. Let's add some fixtures as children of our truss. For example, we'll use 4 Ayrton Revalue fixtures with fixture ID 101. For our target, the marker Actor, we'll also import the set piece added as a child to the marker. Let's import the MVR goat in our patch to add a small piece of livestock. Once imported, name the object and cut and copy it so the goat becomes a child of the Actor marker. Now that we've added all our objects, it's time to enable XYZ functionality for the fixtures we want to control. Go to the Fixture Type Editor, select the fixture types you want to enable XYZ for, and edit the XYZ cell to Yes for the desired TMX modes. This activates the XYZ attributes for those fixtures, allowing them to be controlled by the marker fixture. Let's close the patch and set up the fixtures in 3D. First, we can use the AutoCreateGroups function to create 2 groups. One for all the objects individually, and one for all the Revalue profiles combined. Now, enter Setup in the 3D window and select your marker hoist. Let's position it at 6 meters. Already we can see that the truss and the fixtures follow their parent, or hoist, just like good children should. We still need to rotate our truss on the Z-axis by 90 degrees. Let's now position and align the spots along the truss. Thanks to the parent-child structure, we can easily select them with down. Now that our 3D setup is complete, let's create a sequence with our fixtures at full intensity and their zoom set to narrow so we can track our object with maximum focus. Turn the sequence on. Next, select our Revalue Profiles group and go to the Position feature group. Here you can select more than just pan and tilt, like always. You can now also enter X, Y, and Z values and set the flip behavior for the fixtures. We can also choose a marker target for the selected fixtures. Let's choose our Actor marker. Now the fixtures will track the Actor marker. Store this in a sequence, label it, and turn it on. If we now select our marker Actor and move it around, you'll see the fixtures stay locked onto the Actor marker. Next, let's create a sequence with 2 positions for the actor marker. Edit the sequence, add 7 seconds of fade time, and change the trigger type to follow. Label the sequence target and start it. This looks great. Now let's try moving our truss hoist. Select the marker hoist and give it a Z value. These values are relative to the actual position of the hoist in 3D, so let's give it -3. You can also add some rotation on the X-axis to simulate 2 hoists attached to 1 truss. Store this as the first cue of a sequence. For the second cue, bring the hoist back to 0 meters and rotate the X-axis on the other side. Edit the sequence, give all cues a fade time of 7 seconds, and change the trigger type to follow. Now activate the sequence. We can see our spots are following the object, while the truss is at variable heights and angles, doing exactly what markers are made for. The XYZ values for our fixtures are now set to 0. If we line our fixtures along the X-axis, we can see that the console keeps the intended alignment intact, regardless of the hoist's movement. Of course, you can link your marker fixtures to PSN input for real-time tracking. By integrating with external tracking systems, you can move your marker fixtures based on live data, allowing for synchronized movement with tracked objects or performers on stage. We hope this tutorial sparked your creative ideas. Happy programming!